Hello and welcome to the first lesson in a series that is designed to systematically teach pharmacology, the study of drugs. This short video and the one to follow will serve as an introduction to the nature of drugs. We will discuss some chemistry, some chemical nomenclature, and focus on one exceptionally important class of drugs. Although the importance of these first two lessons may not be immediately apparent, understanding the chemical nature of drugs will make it possible to understand how drugs affect the cardiovascular system, a topic we will get to in subsequent videos. To get the most out of these lessons, you should have a basic understanding of chemistry and physiology. Because each of these short videos is foundational for successive lessons, I strongly recommend that these are viewed in the order presented. We will begin by examining the chemical nature of drugs. First of all, drugs have a chemical structure that, like other structures, is usually made up of building blocks. In order to understand drugs, we need a basic understanding of the functional groups of atoms that form these chemical building blocks. We will commence by considering 5 of these common functional chemical groups. One of the simplest building blocks is the hydroxy group, that consists of an oxygen atom and a hydrogen atom. The name hydroxy is obviously derived from the words hydrogen and oxygen. A second important chemical functional group is derived from ammonia. Ammonia is a compound containing nitrogen and hydrogen and has a molecular formula NH3. If one hydrogen is removed from an ammonia molecule, it becomes an amino functional group, molecular structure NH2. The substituent NH2 is referred to as an amino group, and drugs that contain an amino group are known as amines. A physical property of amines is that they often have a characteristic ammonia smell. Methane has a chemical formula CH4. Removing a hydrogen atom from methane results in the derivative functional group referred to as a methyl group, CH3. In this lesson, we will also consider the 2-carbon ethyl group that has a molecular structure CH2CH2, and finally, the phenyl group that consists of 6 carbon atoms bonded to each other and to hydrogen in a hexagonal planar aromatic ring. Now let's combine 3 of these building blocks to create a pretty simple but exceptionally important drug. Visualize bonding a phenyl group to an ethyl group and then the ethyl group to an amino group. According to chemical nomenclature, that compound or drug is named phenethylamine. Fortunately, we are going to discover that much of this nomenclature is fairly straightforward. Now let's further examine phenethylamine. Specifically, let's consider the ethyl carbon atoms in this compound. It is convenient to differentiate the 2 ethyl carbon atoms contained in phenethylamine. We call the carbon atom that is attached to the nitrogen atom the alpha carbon, and as you probably guessed, we refer to the carbon atom that is bonded to the phenyl group as the beta carbon. Notice that we can represent the chemical structure of phenethylamine in several ways. Now let's keep going and make another more interesting drug. Look at the alpha carbon of phenethylamine. It is bonded to 2 hydrogen atoms. Imagine removing 1 hydrogen atom and replacing it with a methyl group, CH3. According to chemical nomenclature, the resulting compound will be named alpha-methyl phenethylamine. Although alpha-methyl phenethylamine is a valid chemical name, it's just too much to say, so we will refer to this compound by the generic name that I'm sure you've heard of, amphetamine. Many generic names are shortened form of longer chemical names, and in the field of pharmacology, we often refer to drugs by the generic name rather than the chemical name. Now you should realize we have more building blocks at our disposal, so let's continue building a bigger chemical structure. Consider the amphetamine amine group. The nitrogen atom is bonded to a carbon atom and to 2 hydrogen atoms. If we remove 1 of these hydrogen atoms and replace it with a CH3 methyl group, we have another drug you have heard of, methamphetamine. Notice again that there are various ways we may depict each of these chemical structures. We still have 1 more unused building block, so let's make 1 more important drug. As we examine the methamphetamine beta carbon, we see that it is attached to 2 hydrogen atoms. We will create our last drug in this lesson by removing one of these hydrogen atoms and substituting a hydroxy group. The resulting compound is known as ephedrine. Ephedrine is a naturally occurring alkaloid found in the plant genus Ephedra. Ephedrine is known as a substituted amphetamine, and as we shall see in our next lesson, it is also similar in molecular structure to epinephrine. Note that when we compare the chemical structure of ephedrine to that of methamphetamine, there is only 1 atom difference between these 2 compounds. Okay, we are done with drug building. Let's wrap up this lesson by discussing a bit of chemical nomenclature. The prefix meth, meth, signifies the addition of a methyl group. Recall that when we added a methyl group to amphetamine, we created methamphetamine. Conversely, the prefix nor, signifies the absence of a methyl group. Remove the N-methyl group from epinephrine and you have norepinephrine. In many parts of the world, these compounds are known as adrenaline and noradrenaline. Another example, if you remove the N-methyl group from morphine, you have normorphine. Likewise, the N-demethylated derivative of codeine is called norcodeine. The generic name for Demerol is meperidine, or in some parts of the world, pethidine. How do you think the liver converts meperidine to normeperidine? The answer is that a liver enzyme removes the methyl group from meperidine to create normeperidine. And finally, the suffix -ine signifies that a drug is an amine and contains an amino NH2 functional group. Examples are numerous and include drugs such as atropine, morphine, cocaine, codeine, nicotine, strychnine, quinine, caffeine, dopamine, and ephedrine. Naturally occurring organic amines are also referred to as alkaloids. Alkaloids are derived from plants and produce physiologic effects in humans. The term alkaloid, which is related to the word alkaline, signifies that these compounds are organic bases. This is the end of our first lesson. Stay tuned for the next lesson where we will examine dopamine, norepinephrine, epinephrine, and a few other essential naturally occurring phenethylamines. We will conclude with a few figures for your review. If you like this video, please hit like or subscribe. Thank you.